Good morning, students. Today, 26th March, Lecture 1, Chapter 1, continue. Topic is electric dipole. Electric dipole. What is meaning of dipole? Di means two. Two pole means two charges. A system of two equal and opposite charges separated by a finite distance is called an electric dipole. Electric dipole means two charge but equal and opposite charges. If I have one charge plus 10 coulomb, another charge minus 10 coulomb, and if they are separated by some finite distance, then these two charges form electric dipole. They form electric dipole. In general, we can write, if I have one charge plus q, another charge minus q, separated by distance 2a, then this system of charges is called electric dipole. One negative charge, one positive charge, separated by finite distance, they form electric dipole. As shown in figure, the two electric charges of electric dipole are plus q and minus q. And them is 2a. Distance between them is 2a. Now, this electric dipole has electric dipole moment. And how to define electric dipole moment? What is its definition? Electric dipole moment of the system can be defined as electric dipole moment is equal to magnitude of charge into distance between them. Electric dipole moment is denoted by P is equal to magnitude of charge Q, distance between them 2a. So it is equation of electric dipole moment. P is equal to Q into 2a, charge into distance between them. SI unit of electric dipole moment, Q, charge, its unit is coulomb, 2a, distance, its unit is meter. So it is coulomb meter, not centimeter, it is coulomb meter. Electric dipole moment is vector quantity. Therefore, its direction is important, and its direction is from negative charge to positive charge. See in figure, what is direction of electric dipole moment? It is negative charge, it is positive charge. So direction of electric dipole moment, it is from negative charge to positive charge. Negative charge to positive charge. So remember, direction of electric dipole moment is from negative charge to positive charge. Now you have to remember some points related to electric dipole. Net charge on an electric dipole is 0. One charge is plus q. Another charge is minus q. So what is total charge of electric dipole? 0. But its electric field is not 0. Because we know that due to plus q and minus q charges, direction of electric field is same. If q tends to infinite and 2a tends to 0, means distance between them is negligible and magnitude of charges is more, then the electric dipole is called a point dipole. So it is one definition. What is point dipole? If q tends to infinite and 2a tends to 0, then electric dipole is called point dipole. Now, for electric dipole, you have to remember two cases. What is axis and what is equator? An imaginary line passing from two charges is called axis of dipole. See, imaginary line passing from two charges, it is called axis. Its perpendicular bisector is called equator. is called equator. So now in next lecture we will study, okay, what is electric field on axis and what is electric field on equator. Now we will find electric field of dipole. In our textbook NCERT syllabus, we have to study two cases. First, electric field at the point on the axis of dipole. See, it is dipole. Plus q charge, minus q charge. Separated by distance 2a. So it is called dipole. Imaginary line passing from two charges is called its axis. We want to find electric field at a point on the axis of dipole. So, see, it is its center. I am taking one point P on axis at a distance r from center on side of plus q charge. Clear? Let the point P be at a distance r from center of the dipole on the side of charge q. At this point, you have to find electric field. Very simple question you have to ask. At point P, electric field is due to, obviously, due to plus q charge and due to minus q charge. See, we will find electric field at point P due to plus q charge. Electric field is vector quantity, so we will write magnitude and direction. E plus due to positive charge, plus q charge. 1 upon 4 pi epsilon 0. Q, distance. See in figure how to find distance. Distance of point P from plus q charge means this distance. Okay, this total distance is 2a. So this distance is a. This distance is also a. Clear? This distance is r minus a. This total distance is r. It is a. So this distance is r minus a. Clear? So r minus a whole square. Now what about unit vector p caret? What about unit vector p caret? See here in figure. What is direction of electric dipole moment from minus q to plus q? From minus p to minus q to plus q. Okay, from negative charge to positive charge. At point P, due to this plus q charge, electric field is due to positive charge towards or away. Yes, it is away, means in this direction. It is direction of E plus. See, direction of E plus is in direction of electric dipole moment, means electric field due to positive charge is in direction of electric dipole moment. So here you have to write p caret, which is unit vector in direction of electric dipole moment. Clear? Similarly, electric field at point P due to minus q charge, E minus 1 upon 4 pi epsilon 0. Q. What is distance? See in figure here. This total distance is r. This distance is a. So what is total distance between minus q and p? It is r plus a. Quit out. Okay. So 1 upon 4 pi epsilon 0 q upon r plus a whole square. Okay. Now what about the direction? Minus p caret. What about direction? Minus p caret. See, at point P, electric field due to negative charge, towards or away? It is towards. Towards means in this direction. In this direction. So it is direction of E minus. It is direction of E minus. See, E minus is in opposite direction of electric dipole moment. In opposite direction. So E minus is in opposite direction of electric dipole moment, means you have to write minus p caret. Clear? Now you have to simplify mathematical steps. What is total electric field at point P? E is equal to E plus E minus. E plus E minus. See, 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0. Q and Q common. Okay, 1 upon r minus a whole square, negative sign, minus 1 upon r plus a whole square. unit vector p caret. Clear? See, q upon 4 pi epsilon 0, q upon 4 pi epsilon 0 common. From this first step, 1 upon r minus a whole square minus sign 1 upon r plus a whole square and p caret here. Clear? Okay. Q upon 4 pi epsilon 0 as it is. Now cross multiplication. See carefully. R plus a whole square. What is r plus a whole square? We know that it is r square plus a square plus 2ar. R square plus a square plus 2ra. Clear? Then it is negative sign. R minus a whole square. What is r minus a whole square? It is r square plus a square minus 2ra. But here we have negative sign. The sign of each and every term is changed. R square minus r square. A square minus a square minus 2ra. It is plus 2ra. Clear? Okay. So it is simplification. In denominator, r minus a, r plus a. We know that a plus b, a minus b is equal to a square minus b square. But here we have r minus a square, r plus a square. So we can write r square minus a square whole square. Clear? Now r square, a square, cut. Q upon 4 pi epsilon 0, Q upon 4 pi epsilon 0. 2ra plus 2ra, it is 4ra. R square minus a square whole square. R square minus a square whole square. P caret as it is. Clear? Okay. Now, E is equal to 1 upon 4 pi epsilon 0. This 4 is divided. See, this 4 is divided. Q into 2a, 2r. 4 is equal to 2 into 2. Q into 2a into 2r. Denominator as it is. Now Q into 2a, we know that Q into 2a is electric dipole moment. So Q into 2a is replaced by P. So what is your equation? Electric field on axis EA is equal to 1 upon 4 pi epsilon 0 2rp upon r square minus s square whole square P caret. If R is very greater than 2a, or we can say if for small dipole, when R is very very greater than 2a, in denominator with respect to this R, you have to neglect a. Okay, so E is equal to 1 upon 4 pi epsilon 0 as it is, 2rp as it is, r square minus a you have to neglect. So write a is equal to 0. So r square whole square means r raised to 4. R raised to 4, so it is r cube. So it is equation of electric field on axis when r is very greater than 2a. Okay. Now electric field at a point on equator of dipole. See again, plus q charge, minus q charge, separated by distance 2a. It forms electric dipole. Yes, it is center O. This distance is a. This distance is also a. O is midpoint. Perpendicular bisector. It is called equator. Now we have to find electric field at point P at a distance r from center O. Clear? Again, at point P, electric field is due to plus q charge and minus q charge. See, it is A, it is R, right angle triangle. So what is this distance? Under root r square plus a square according to Pythagoras theorem. Similarly, this distance is under root r square plus a square. Magnitude of this charge and magnitude of this charge equal. Distance equal. So, the magnitudes of electric field due to the two charges plus q and minus q are given by E plus is equal to E minus. They are equal. Why equal? magnitude of charges are equal and distances are also equal, is equal to 1 upon 4 pi epsilon 0 q upon distance square. Distance square. See, what is distance? Under root r square plus a square whole square. So square and square root cancel out each other. So E plus is equal to E minus is equal to 1 upon 4 pi epsilon 0 q upon r square plus a square are equal. Now, directions. See in figure carefully. Due to this plus q charge, direction of electric field at point P, due to plus q charge, it is away, so it is E plus. Now we have to resolve this E plus in two components. One this and another. Now this component is called, see, parallel to axis. It is called parallel to axis, and this component is called perpendicular to axis. It is called perpendicular to axis. So you have to resolve this electric field in two components. One parallel to axis, perpendicular to axis. Now to find components, we need angle. We are assuming that this angle is theta. So this angle also becomes theta. E plus is making angle theta with this component. So it is called E plus cos theta. Clear? And this component is E plus sin theta. Any doubt? Okay. Now, due to minus q charge. Due to minus q charge at point P, what is direction of electric field? Towards or away? Towards, because it is minus charge. So it is E minus. It is E minus. Clear? Again, you have to resolve E minus into component. One parallel to axis and one perpendicular to axis. We have assumed this angle theta. This angle is also theta. So this angle will again become theta. As E minus is making angle theta with this component is E minus cos theta, and this component is E minus sin theta. Clear about components? E plus, two components. E minus, two components. Now see, from figure it is clear. E plus sin theta and E minus sin theta, they are of equal magnitude and in opposite direction, so they cancel away. It means components normal to the dipole axis cancel away. Clear? So at point B, resultant electric field is only due to components parallel to axis. Only due to component parallel to axis. Clear? Okay. Now see, these two components, E plus cos theta and E minus cos theta, are in which direction? Minus q charge, plus q charge. So it is direction of electric dipole moment P. It is direction of electric dipole moment P, and these two components are in opposite direction of electric dipole moment. So you have to write unit vector in opposite direction of P. See in last column, the total electric field at point P, E is equal to E plus cos theta plus E minus cos theta minus P caret. Why minus P caret? Because E plus cos theta and E minus cos theta are in opposite direction of electric dipole moment. Clear? Okay. Minus E plus E minus cos theta common, P caret, minus E plus E minus. E plus is equal to E minus, we know that. So we can write 2 upon 4 pi epsilon 0 q upon r square plus a square. Now cos theta from figure. Cos theta you have to find from figure. Cos theta you have to find from figure. Cos theta is equal to adjacent side upon hypotenuse. cos theta is equal to adjacent side upon hypotenuse. So it is a upon under root r square plus a square. Okay, so write cos theta is equal to a upon under root r square plus a square. Clear? Now we have to simplify. See, e is equal to minus q into 2a 4 pi epsilon 0 r square plus a square power is 1. R square plus a square power is 1 by 2. What is 1 plus 1 by 2? Yes, 3 by 2. So r square plus a square whole raised to 3 by 2. Clear? Q into 2a, it is called electric dipole moment. So it is equal to minus Q into 2a, it is P caret 4 pi epsilon 0 r square plus a square raised to 3 by 2. So it is electric field on equator. Now when r is very greater than 2a, or we can say for small dipole, again with respect to r, you have to neglect a. You have to neglect a. So E, that is electric field on equator, is equal to minus P caret 4 pi epsilon 0 r square plus a is equal to 0. R square is to 3 by 2. Square and by 2 cut. So it is only r cube. It is only r cube and it is P caret. So it is electric field on equator. It is electric field on equator. See, what is conclusion of this two theory? For small dipole, or when r is very greater than 2a, E is proportional to 1 upon r cube. E is proportional to 1 upon r cube. And for point charges, E is proportional to 1 upon r square. So it is difference between electric field of small dipole and electric field of point charges. So it is one topic, electric dipole. What is electric dipole? Electric field due to dipole, two cases, on axis and on equator. Write it down in your notebook. For knowledge students, you have to send these notes on my WhatsApp number. For other school students, you also have to write in your notebook and send to your respective subject teachers. Thank you.